Like, comment, subscribe, and let's do this.
Ready? Inside the stomach of a sperm whale, there's an alarming amount of colossal squid. And look at this thing, it's huge! And scientists think something like 80% of a sperm whale's diet is this gigantic animal. Which means there's gotta be tons of them in the ocean, right? How hard could it be to find a live one in its natural habitat? Based on what we know about sperm whales, we figure these colossal squid primarily live here, deep in the ocean. So to get there, we'll need a special submersible. Down here, sunlight can't reach. But wait, all around us, there's
4,000 meters.
Kilometers in every direction. There's nothing else. We strain our eyes to see. We're searching and searching because the ocean is so much bigger than most people think. An adult colossal squid can be over 9 meters long. But down here in our sub, it's like looking for a housefly in an arena with the lights off, using only your phone's flashlight, and the weather's bad. So
That's crazy.
It's not looking great for our expedition. Hello?
Her saying that really puts it into perspective, like, it's not easy to find one. If you really think about it, how big the oceans are and how small we are, it would prove nearly impossible to find these things. But they are huge though. 9 meters. That's huge.
Fortunately, in 2025, 100 years after we first realized the colossal squid existed, we got incredibly lucky. Researchers caught this footage of a young one, an absolutely unbelievable find, entirely by accident. Just like this footage of an oarfish, or this genuinely terrifying footage of a big fin squid filmed by oil rig operators.
What's that?
That gigantic, monstrous, beautiful, bizarre animals thrive in the cold depths of our oceans. But up until now, most of our discoveries have just been right place, right time. But what if I told you there's another way to discover the giant animals in our deep sea, and all we need is a drop of water?
What?
If you dive into the ocean searching for life,
You know what? Now that I think about it, human beings are I was going to say creatures in the ocean are alien-like. But now that I think about it, in contrast to other animals, apart from like maybe chimpanzees and, human beings are almost alien-like. Like, look at yourself and look at something that lives in the ocean. The difference in the way we look to other animals is so insane. But yeah, I won't be pausing a lot, so I'm sorry for pausing twice already in 2 minutes.
if you dive into the ocean searching for life, you want to be prepared with the right tools, and that depends entirely on how deep you plan to go. For the first 30 meters or so, you can use scuba gear to dive and look around. There's plenty of light here, and we've spent tons of time studying these places. But despite that easy access, we still keep finding new species all the time. Experienced divers can go way farther, all the way down to about here. But they can't stay there long, so sometimes they leave experiments like these artificial reefs to pick up later. These were recovered in 2025 and unveiled around 20 entirely new species. But the farther down we go, the harder it gets to explore. By the time you get here, the pressure would make it feel like your entire body is being squeezed. So scientists use specialized underwater robots. Some work autonomously, and then they store data or video that's then retrieved after the dive. Others are tethered to a ship and send back data almost instantaneously. These can even have sampling arms, and they're equipped with all these cool different sensors. But when you turn on the lights down here, the first thing that you see is pieces of scales and poop and dust and dead animals that drift down from the surface. This is nicely called marine snow. It's a really important food source for the animals down here. Because sunlight struggles to reach this layer, we're not seeing much at this point, but the animals that we do see are so cool. Lots of them are transparent, or they glow in the dark. It's like a whole alien carnival happening down there.
Looks like
scientists
Tokyo.
discovered that there's something very weird happening in this part of the ocean. During World War II, sailors noticed this mysterious shadow on their sonar. It looked like the seafloor was only a couple hundred meters below them. But what was alarming was that it was moving. Every night, this giant shadow would rise several hundred meters, inching closer to the ships, but every day it would drop away again. We later learned this wasn't the seafloor, and it wasn't some hidden fleet, and it wasn't some giant monster. It was the world's largest migration. Billions of tons of animals leaving this dark zone to feed in the upper layer at night.
Every single night, it's more biomass moving than like the Great Migration in Africa.
Which means that hidden somewhere in all this empty is actually one of the most crowded places on Earth.
These things look so cool, bro.
Today we know that this giant shift happens all over the world. It's so big, it actually churns the water, and it's really important for the health of our planet. At the surface, phytoplankton pull carbon dioxide out of the air, and every night billions of animals come up from the deep to eat those phytoplankton, bringing all that carbon waste deep into the sea, which speeds up how quickly it's removed from our atmosphere. Today, we still use sound waves to study this zone. Different frequencies hint that there might be billions of tons of elusive animals down here. But sound alone can't tell us exactly what kinds of animals.
And there's lots of unknown questions about who's moving? Are they moving every night? Is it different species? Some come up earlier, some come up later. Why do they do that?
We have specialized nets, but many of their soft bodies break apart, and lots of them just avoid it entirely. So we try to see them, but the trouble is that lights and motors can scare away animals adapted for dark, silent isolation. We did find a giant monster down here, but it took so much work. In 2012, scientists used a red LED light, invisible to most animals down here, and removed any motors to reduce noise. And then they attached a special lure that flashed blue to mimic a certain jellyfish. They dropped it 700 meters deep, and then a giant squid appeared, filmed for the first time in its natural habitat. But that's not a colossal squid. Giant squid and colossal squid are different. And this took a lot of engineering, 20 years of data on the whales that eat these giant
20 years and probably millions and millions invested into this just to see a squid, bro. Just to see a squid. Isn't that insane? Imagine being that person who's invested millions and millions and then putting your whatever vehicle you're using to try to see these things in action and failing and then like failing. That would be so, I bet it was so frustrating too. But let's see what she has to say.
Over 100 dives and hundreds of hours just waiting to get these few minutes of footage. That's a huge amount of time, money, and resources for just a few minutes. But we want to go deeper.
Man.
It's dark here. I mean, pitch black.
Oh.
Any trace of light is quickly absorbed. We're in the largest single habitat on the planet, accounting for 70% of all seawater. And we know that giant animals like that squid haunt this place because we see the scars left behind on whales. But what else? A brand new, monstrous, beautiful species could be lurking right outside our field of view, and we would never know it. This is a major problem with deep sea ocean exploration so far. You just gotta get so lucky. Most of what we see down here are scavengers, but we're still diving. Now, welcome to the abyss.
The abyss.
It looks like a desolate desert here, with vast plains of mud and minerals, little metal spheres that have gained a lot of attention for deep sea mining recently. But also, alarmingly gigantic animals, like this 40-centimeter long isopod. That thing is 16 times bigger than its terrestrial relative. Or these 30-centimeter long amphipods that are over 10 times larger than their shallow water counterparts.
Kind of looks like a cockroach, doesn't it? It looks like a cockroach. I suppose, like, I don't know if that's how you say it, but They always look like cockroaches to me. And I do wonder, like, if you're living that deep in the ocean or that deep in the sea, do those animals feel the need to evolve? Or they've been like that for millions and millions of years? If somebody knows that, put that in the comments because I don't see why they would feel like there's a need to evolve. Nobody fishes for deep sea creatures, nobody eats them. You know, it's the same ecosystem, I'd like to think. But if I'm wrong, put that in the comments. I do wonder though, do they evolve? Or if they've just been like that since the inception of their kind?
We still don't fully understand why these animals grow to these enormous sizes down here, but our best guesses are that larger animals can go longer without eating and have slower metabolisms, which is great for a food-scarce environment. One of these giant isopods went 5 years without eating in captivity.
5 years?
Another is they evolved in isolation, which lets them grow to massive sizes without getting eaten.
Damn.
And the final one is about temperature, because it's freezing down here, 0 to 4 degrees Celsius. Colder water holds more oxygen, and freezing temperatures cause life to move in slow motion, letting cells grow to enormous sizes. You see this in the freezing waters around Antarctica, which results in something called polar gigantism. We think this is what led to the colossal squid. And these gigantic sea spiders. Oh my god, the ocean is terrifying. Hey, look, the Dumbo octopus. He's so cute. He comes down here sometimes.
He is
We're
cute.
still going even deeper into the Hadal Zone. Trenches here are deeper than Mount Everest is tall, and the pressure feels like 100 elephants standing on your head. And yet, we're still uncovering tons of life. We've gotten really
pressure.
good at improving our tools for exploring the ocean at all levels. But the big point here is, it's often expensive and time-consuming and even dangerous, which is why so much of what's down here is still invisible to us. We needed a new tool. Ideally, a cheaper one that can give us a really broad view of our oceans and all of the life here, and help us find that fly in the arena. And now, we have one. So I'm using this special water sampling kit, but to buy this and all of the equipment that we use, from our mics to our cameras to the
this is an
software that we're
ad.
gonna use to edit this video, I used this. This is my real Mercury card. Mercury is the tool that I've used since Huge started to manage our finances. I can prove it too. This syringe holds traces of thousands of animals. I collected this sample from the Hudson River, so really who knows what's in here. But this is the same thing that scientists are doing in the deep ocean. All the way down through our oceans, life takes many different forms, but they all have something in common. They shed that snow. The feces and mucus and random scales and tissue particles.
So they essentially leave behind like little signals of who they are.
Sometimes I just get told I just study poop all day, but there's all kinds of junk that's left behind. And we get all the way from bacteria to fish, all the way up to whales and sharks.
So if we dip into that water, pull it up and filter it, we can use those little pieces to extract DNA, environmental DNA.
But you know what's crazy? I'm like thinking right now, like, I know not a lot of governments and all that invest into ocean exploration or sea exploration. I just know they would. If they found like some kind of mineral that's so expensive or a way they could make money out of it, oh, we would know about the ocean, I'm telling you. We would know all sorts of things about the ocean. But in that process, I'm telling you, the ocean would be decimated. So it would be like knowing those things in exchange for the death of those things. That's just how it is, and it shouldn't be like that.
eDNA. So what can you do with just a little bit of water? You can do two things. The first is you can chase a specific animal
My
that
nose
you
is
already know
itching.
exists. Go find your fly in the arena. Imagine the ocean is a giant bowl of alphabet soup, and you put your spoon in there and you sample it, but you're only looking for the letter A. researchers will use short, single-stranded DNA sequences as a sort of magnet. These will ignore all of the other letters in your soup and latch on to only the one that you want.
We can say, well, they were here. We know they were here.
And we've done this. This is an angel shark. It's critically endangered.
Angel shark.
And it's also an ambush predator that's really good at hiding. So for years, the only way that we saw them was when they were accidentally scooped up by fishermen or just luckily spotted by divers. And so for a while, we thought they were extinct in this one particular area. But then researchers sampled the water and they found spikes in angel shark DNA. So they sent the divers directly there, and sure enough, they found them. That sort of thing could help
That's
us
so
really quickly
cool.
find and protect and learn more about all kinds of species. It's being used right now to protect this guy and many others. This method can be faster than
What's
traditional
that?
methods and way less invasive.
Ocean
and speaking of invasive, we can
platypus?
also use it to identify where invasive species are. If one shows up in a port or in an area where it's not supposed to be, a dive team can really quickly go in and remove them. But what about searching the deep ocean for animals that we know are there, like the colossal squid?
We are actually doing that right now in Antarctica. There's a group from New Zealand trying to take samples, and that's our goal, is to try and identify all of the cephalopods in the samples and try to actually see the colossal squid.
This could be so helpful compared to the luck that we need now.
If you're sending a person out to look, they have to be there right at the right time. And so this is another way for us to sort of look backwards in time and say, well, was it here a day ago or 2 days ago?
With enough sampling, there's a future where eDNA could tell us, hey, there's a lot of colossal squid DNA right here all the time, which could let us create heat maps of the animal's range. And it's not impossible to imagine a future where it doesn't take 20 years of whale studies to find a giant
That's so
squid,
insane.
or 100 years of just waiting for a lucky break. That is, by itself, incredible. But here's what I find most huge if true. What if we don't need to know who we're looking for? This is the second thing that you can do. You can hunt for the unknown. You remember this migration? Well, if we know that something is there, there's a good chance that eDNA can tell us who it is and at what times. So during the day, researchers go out and they collect liters of water from the surface and the twilight zone area to catch traces of hundreds of species at once. And instead of searching for one specific letter in that alphabet soup, they use something more universal, like find me all the vowels.
Bruh, I'm listening to this and I'm trying to comprehend what she's saying, but I cannot stop thinking. Technology is so insane. And ever since the 90s, the rapid acceleration or evolution of technology has been so crazy. The technology we have now, if somebody from the 90s were to time travel to now and look at it, I bet you they'd be so mind blown. Because what do you mean you could go to the ocean with a syringe and just take the water out of the ocean and go test it, and you could tell oh yeah, an angelfish was here. That's so insane to me. Soon enough, I'm telling you, we're going to be grabbing DNA out of the air or something like that. I wouldn't even be surprised if somebody said, oh, that already exists. That's how insane technology has gotten.
And this will flag a bunch of species and then sort them based on the differences in their genes. And later, scientists can go back out and repeat the same process at those locations. So then, if you look at the changes in the DNA samples during the day versus the night, suddenly we have a much clearer picture of who is migrating at what times. And we're doing this hunt for the unknown in the deep sea as well.
For us biodiversity scientists, it's the last frontier of exploration.
What she found with just water was incredible. A world that we'd never seen with our eyes.
We're seeing that there is hotspots of biodiversity, and we're detecting these amazing creatures that no one's really seen before or recorded before.
A shark that we've only seen a handful of times. Giant squid. Even one animal that we so rarely see we once thought it was entirely extinct. All detected with just water.
It's a really proof of concept that we can detect really small things in these huge kilometer scales of water.
But most exciting to me is when researchers first sampled this area of the abyssal plain. What they found was shocking. You are never going to see the ocean the same way, because of the DNA that came back, 90% of it was unknown. 90%! They call it dark taxa. We think there are over 2 million different marine species in our oceans, and estimates say that we have documented less than 10%. When we sample water and sequence DNA, we still have to compare that to the databases to find out what it is. But since we don't have the genome for nearly 90% of life in our oceans, a lot of it comes back unknown, especially in the deep. These might be species that we know about but never genomed, or it could be something in...
Hey, if they gave me the powers to like explore these places, bro, I'd be naming everything. I'd be naming everything so bad that they have to change the laws on naming the animals. I would name everything. What would you do? Would you like leave it up to the scientists to name them? Or you'd like name them yourself? I know what I would do, bro. Every day, coming up with funky names for everything. Scientists would be sick of me.
Entirely new. Researchers are starting to use machine learning and AI to help fill in those gaps. And the hope is that this could take dark taxa and group it into similar groups. So you could start to say, this unknown animal kind of looks like this one that we do know.
We're trying to see like what is like the other. This looks like squid. Is it squid?
But to do that, you need data. So that's the true new frontier of ocean discovery. Right now, we're in a big race to sequence our oceans. And the cool thing is we can preserve these eDNA samples and run them again years later with new information. For now, it's a bit of a black box. And that's okay, because unlike our ROVs where we can only guess that something is lurking behind us, eDNA is telling us, hey, something is here. We just might not know what yet.
This is just so cool to
me. This
me.
is easy. No, this is hard. For one thing, some animals shed more than others. DNA degrades really quickly in shallow waters. In the deep, it stays longer, but it's harder to collect. It's complicated. But the need to go deeper, to learn more, is more urgent than ever. Our planet's biggest ecosystem is changing faster than we can understand it. But fortunately, so is our technology to learn more. Because eDNA doesn't just give us a glimpse at what might be hiding, it also gives us a baseline for the health of our oceans.
It's sort of like a totally different type of medical test for the environment that we can start to look at.
And we can show it to the world and show them that these are really exciting habitats that are worth us caring about.
And what's really cool is that anybody can be involved. They ask for samples from all over the world. I'm gonna send off my sample and see what we find.
As it gets better and
I
as
don't
we put
live
more
near
effort
the
and time
ocean.
into this, it's just going to explode. And our applications in the deep sea we haven't even scratched the surface of what we can do yet.
But as we continue to learn more, we'll find new tech and new life and new ghosts in the deep, calling for us to go find them.
This, man. This was so cool, man. And it's so insane that we have we know only 10% of the creatures living in the ocean. You would think by now we'd know a lot, but we know more about space than our own ocean, which is so insane. But I learned something today. If you want me to react to more videos like this one, put the links to the specific videos in the comments and I'll get to those videos and react to them. And on that note, thank you for watching and I'll see you on the next one.